Hello physics class, it's Mr. Ng with sample B out of your Holt physics book. This problem is all about impulse, and it goes through two equations about impulse. Number one, impulse, let's just walk through it now. Impulse we're going to write as delta P, the change in momentum, because impulse is the change in momentum, meaning it's how momentum changes. So the final momentum minus the initial momentum. And if you want to get all fancy with it, you could rewrite that as in delta P is equal to m times v final, right? M times v, that's momentum, minus m times v initial, right? The change in momentum, okay? But there's a second equation, so here's our equation 1. Our second equation goes like this, that impulse is equal to force times time. Good? Let's walk through this. A 1,400 kilogram car is moving westward with a velocity of 15 meters a second and collides with a utility pole and brought to rest at 0.3 seconds. So let's go through and kind of label these variables. 1,400 kilograms, this is our mass, and it's not going to change. We don't need a mass 1 and a mass 2. It's the same mass. But this velocity, is it the beginning velocity or the final velocity? You're right. It's the beginning velocity, so v initial. Hey, just so you know, our v final is 0, right? The car crashed into a post and it stops, meaning our final momentum is going to be 0. So that's going to help us. And then finally, we do have a little bit of time here. I'm guessing we're going to use that for equation 2. Okay, let's break this down a little at a time. It wants to find the force, but really, we should first find the impulse. So here, number 1, find the impulse. To find the impulse, I'm going to use equation 1. Delta P is equal to mv final minus mv initial. I'm just going to do some plugging in. Delta P is equal to 1,400 kilograms times v final, which is 0, minus 1,400 kilograms times v initial, which is 15 meters a second. So my delta P is equal to 0 minus, I'm just going to type in the stuff here. Oops. Let's get rid of all this. 1,400 times 15, 21,000 minus 21,000 kilogram meters a second. So my impulse is equal to negative 21,000 kilogram meters a second. Good. Part 2, I'm going to try to find P. And if you'll forgive me, I'm just going to erase this so I have a little bit of room. Right? Part 2, I'm going to find that force. And I'm going to use this equation, the number 2 equation. The impulse is equal to force times time. And I'm going to rearrange this equation just a little bit so that it becomes force is equal to, right? They want the force. I'm just going to rearrange it to move force by itself. I'm going to divide by time, time cancels. Force is equal to delta P over T. So delta P, I know, it's right here, right? That's my impulse. And T, I know, it's right here. So I just got to plug in. My force is equal to negative 21000 kilogram meters a second divided by 0.30 seconds. So I just need to divide this by 0.3. So 70,000 newtons is equal to 1, 2, 3 kilograms meters a second. Kilogram meters a second, I think you guys remember that that's a newton. So the force is equal to, well, it's actually a negative 70,000, the negative things go away, newtons. Good. So how did I solve this problem? I used 2 equations. The first one is that impulse, delta P, is the final momentum minus the initial momentum, or the change in momentum. My second equation is that impulse is equal to force times time. And I just slowly work through the variables. Thank you very much for watching.